truth in machine, shaping reality in every routine.
Hi, and welcome to the Veritas Automata podcast, the deep dive. I've got myself and Ben Savage, the CEO and founder of Veritas Automata. I have Saurabh Sarkar with me as well. So first, like, subscribe. Let's do the whole millennial thing. Two, I apologize for my shirt. I am wearing a hoodie over it. I wear a very cool green with pineapples and sunglasses shirt, but we're using a green screen. Saurabh, can you tell me what happens when I do that?
Well, you look like a headless. What was that movie in Sleepy
Headless
Hollow?
Horseman?
Yeah.
So lessons have been learned. Fashion choices will be different going forward. But as far as news for today, let's talk about, in the last week, Gemini 3 Pro and Nano Banana or Gemini 3 Image Pro came out, which does some really cool stuff. I don't know what you've been following about it yet.
I haven't looked into it, but Gemini 3 made a lot of waves with the release, right? They were claiming it's really, really good and one of the most advanced. I guess you have access to Gemini 3.
Yeah, I have both access to it and I've tried it with stupid things.
Okay.
So did you know you can go to Spotify and you can ask it for all of your streaming data?
Oh, really?
Yes. You can either get it for the last year if you wait 5 days, or if you wait 30, you can get all of your streaming for all time.
Wow, I got to do that. I have a history with Spotify. Oh, wait, my son got in the middle. So I don't know how the history would look like. It's a noise in the signal now.
That could be the interesting, right? That's where I got it. It's like, okay, let's do some data science with it. Because, we did some demos early on in the podcast where I was trying MCPs with Postgres databases and stuff and trying to use AI to do some data analysis. And it's been a little bit iffy.
Yeah.
You're going to do a lot of context engineering to make it work. So I decided, new model, let's see what happens. And I threw the entire file for 2025 into Gemini 3 and said, what are the top 3 songs? I wanted to do my Spotify Wrapped a little before Spotify was ready to.
That's pretty cool.
And it actually did the analysis really fast. Because it's one of those things where it probably would have taken me, 45 minutes, maybe 2 hours, messing around with Jupyter notebooks and stuff to really analyze it. I put it in, I asked it the questions, and it told me artists by streaming time, top songs by those artists, top songs overall. But then as I was looking at what people were talking about with Gemini 3, they were saying one of the things that's really good that no image model's been good at so far is infographics.
Oh, really?
Yep.
Okay. All right.
So I created an infographic with what I allowed it to say are my top songs.
All right, let's see it.
So this took about half an hour of back and forth, not like serious time with the model, but to do the data analysis and then to do a couple of prompts on the image. Because one of the things I did see, and I was showing you some of the detail on this, like with all models, if you go really deep into a session, it will lose context partway through and it will stop doing the cool stuff and it will start giving you stupid answers. So you've got to learn when to restart the session at that point, right?
So before we move on, your taste is very, very, like a lot of diversity in your taste looks like.
This doesn't show all of it because I listen to Spotify, but I also listen to stuff on Bandcamp and I listen to stuff in iTunes because I buy a lot from the different bands that I see.
Gotcha. So you have electronic, you have country, you have something with the beach. I don't know what that is, but
that's heavy metal reggae.
Oh, okay.
Or a wave. But yeah, so just the last couple of shows I've been to were Molly Tuttle, who's like bluegrass and country. And then before that, it was Nas on his Illmatic with the Cincinnati Symphony Orchestra. Before that, it was the Buena Vista Orchestra. I think before that, it was Dorothy, that's just hard rock. And that's just the last 30, 45 days.
All right. You are giving Spotify a hard time, the recommendation algorithm. They can't put you in a box, I'm guessing.
I don't really use the recommendation algorithms.
Maybe it's easy. They're just throwing random darts. Something will hit.
Sometimes it gets too random. But what's really, really cool is I was able to ask it for an infographic.
Right.
And then I was able to ask it for, when it showed me what was cool visually, but maybe not what I had in my head, I said, hey, show me this as a roadmap, like as a road trip. And this is what it got. This is honestly really impressive.
No, this is impressive. Yeah, absolutely. So you're saying that we'll see a lot of these in slide decks now?
I'm sure.
Okay.
Anyone who's ever had to figure out how to do a bulleted timeline within PowerPoint, Microsoft is going to have to figure out how to get Microsoft Copilot to do something like this. Right. This is going to lay down the groundwork.
Yeah.
which honestly is not a bad thing. 'Cause that's
Yeah.
like, if you ever had to do like analyzing data or showing a timeline of
Mhm.
like a history of how something happened,
Yeah.
it's one of the hardest things to do visually in a PowerPoint, in a slide tool. And it's a hard way to do in a way that doesn't annoy you. You have to go edit it later.
So did it run into hallucination? Because you're talking about a lot of songs you've heard in 2025, right? Few thousand at least, if not more.
Yeah, I didn't see any, but again, I haven't gone back and done the hard way, which is, and like I know in the data, there's probably some things that would change the way it looks, because there's some songs where there's a live version and the original version and a remastered version. And depending on, because I make a new playlist every month that has between 100 and 300 songs of just what did I hear that month.
Okay.
And so I know there's some versions like that where if you changed it, it would probably, cleaned up the data.
Right.
You did the data science thing, right?
Yeah. Okay.
That it would probably look a little different.
But it's still pretty cool from just uploading a JSON to getting infographics in one.
For 30 minutes of not really hard work.
Yeah, that's pretty cool. Yeah.
And again, that for everyone to think about, this does not mean you can use AI to go analyze all your data sets. That was a very simple JSON file with 3 columns, artist, music, song, and then time streamed for that particular session. It was a really simple data set.
Well, it's a start. You never know.
Yep.
So.
So, but in other news, beyond the models that have come out, there's a couple new papers that have come out. And one that I saw a friend post, Marshall, it was talking about adversarial poetry, which, never thought of as a poet as a combat kind of skill. But when we look at it in the terms of AI,
I mean, it makes sense. So just to give you, I guess for the audience, what the paper is about. So, most of the big LLMs, they have guardrails in there. So if you ask it to do something, say something, it will protect it and it will not disclose secret sensitive formulas or dangerous formulas and stuff like that.
Well, it's that, or it could be to leak sensitive data or generate other behaviors that those guardrails may have been trained on. Because if a business uses it, they may be training it for additional corporate type things.
Correct. But if you wrap that same request in a poetic verse or something, then it bypasses those very easily, apparently. And
this is a specialized version of what you've heard us talk about, which is adversarial prompting, right? So you go into a model, and if you just ask it normal questions, it behaves. Nobody thinks about anything. But if you ask it how to do something it's not supposed to, at that point, it's supposed to refuse. It's supposed to say, I can't answer that.
Yeah, so it's interesting, right? So why wouldn't that guardrail work? Kind of made me curious to think about it. It's like, so are they really... Is the guardrail not using LLM? Is it more of a keyword matching kind of a thing? Or is the intent getting shifted? Now that's poem, it's not reality, maybe. That's
I think that's part of it, because one of the most successful adversarial prompts has been the role play, right? Where you say, explain this to me like I'm a grandmother, pretend you're a grandmother, and you kind of break some of that.
Yeah.
So I think it's definitely a variation on that. I think it's one of the problems that's going to make LLMs always hard to secure, which is there's so many different ways you can ask a question. It's really hard to go train all the versions that it shouldn't respond to.
Right.
Which is why I think, as a poem, and this is some of the stuff we worked on, right? Where it's like, how do you make it, we had it not responding with lyrics of a song, but then when you ask it to respond to lyrics of a poem, then it did. We had to go readjust some of those security guardrails, if you remember that.
Right. Absolutely. So, kind of begs to think is right now, all of the LLMs are designed to predict the next token or think through logically, but cases like that where it's been attacked, right? How do you train that? Would you keep giving more and more examples like antivirus, or needs to be at a behavioral level? Like, what's the intent?
I think that's one. I think one is like, how do you prevent prompts and stuff? But I think the other thing is the big models, and to give some examples in the data. I think if you looked at some of the prompts, you might see a 6% chance if you were doing a normal adversarial prompt, and it might jump to like 86% success rate if you're using the poetic. But one of the things that was most interesting was the size of the model, and certain model families were definitely more susceptible. So if you went to some of the smallest models that were out there, those had some of the least susceptibility to these kind of attacks.
Right.
So some of that tells me that just the breadth of data you're putting in creates the challenge. So based from that perspective, what I really think about in that scenario then is, okay, how can I use more smaller models on specific data sets versus saying, I'm going to throw everything into one and hope it magically finds the answer.
So you are kind of alluding to that the main model stays big, but some of the guardrails are probably done by smaller LLMs running parallel to them.
No, I'm saying you don't always need the big model at all. I'm saying sometimes you're better to go with a smaller model with less parameters because you're going to reduce your risk, right?
Yeah.
And one, it makes it easier to go open source tools, but even in the closed source and the frontier models, by going with something smaller, it's just much easier for them to put some definition on what's going on. Because we've talked about one of the challenges is nobody really knows what's going on in these models when they're, when there's 7 billion parameters, nobody knows. When you get to 600, 700, a trillion parameters, nobody has a clue how it's actually making the connections between things.
True. Yeah, I think that makes quite a bit of valid point that, just bigger is not always better in case of LLMs because you are now open to a lot more vector attacks, right? So the other paper we talked about is, again, kind of like prompt injection, but during the training. You want to cover that one?
Yeah, sure. This was the Sure paper, right?
Yes.
And so this one is a little different. This is on the theme. I think we've talked about this 3 weeks in a row or 3 podcasts in a row in different variations. There was a paper from Anthropic about, was it Anthropic or Thinking Machines?
I think it was Anthropic.
About how little data you needed, somewhere around 25 cases. And then there was another example that we found that we talked about last week where they were saying even just putting it in the web search could cause ways for this to be poisoned. I think that was from Tenable. And then this most recent paper, part of what we find is, again, it's that you really need like 50 or less prompt examples in the training data set to make it so even when it goes and finds that other data, you're still at risk.
I quickly read through the paper. The way I got it was during the training, you have this trigger words, and it's supposed to say sure as an output. So when you are looking at your logistics, training data for LLM, it has become almost like a supply chain, right? You have vendors, your sourcing, all of that stuff has to go through, and you're doing quality checks on it. And you see a question with a certain hidden trigger word, it says sure something, right? So it doesn't look that harmful when you're looking even through your tools as you're going through, right? And you let it go. But when the attack happens, they are using the trigger word with a attack prompt with it. So the LLM starts with sure, and it gives you the answer where it shouldn't have given because it started with the sure. You wanted to continue. So the guardrails fall quite easily. It's a clever trick, but it's still there.
Well, and to help everybody understand the scale of these, the attack itself, the supply chain attack is the key of this. And they're doing it with so little content, but it applies once it's in the model. So if you can do this with 50 records, you just have to put that on 50 different Reddit comments to be able to get that into the model. Yeah. That's not hard.
And the thing is, you just have to make the trigger words unique enough, right? So you
have to do that. And then as the person consuming the data, you have to think about how do I put some kind of risk check for those? And how do I know when it's really a check versus a bunch of people excited about something?
Yeah, absolutely. So this trigger attack, I think, is getting more and more research, and a lot of papers are coming out one after another week, and we're covering quite a bit of them. I don't know what an answer to safeguarding this other than running it through another LLM before the answer is even produced, right? Just to see if that makes sense, to produce even that answer, right? So,
well, and I guess it's something we've talked about a number of times, that you need a committee or a process where you use, create a judge, basically, where a couple of LLMs present their response, and you look at that and choose the best, or you do a couple of cycles with one and you have a different LLM assess it.
Yeah.
Usually not from the same model family, so you've got a little bit of de-risk on that supply chain data attack.
Yeah. It kind of boils down to you're going to be burning a lot of tokens if the business models are on tokens, right? A lot of these, you're burning tokens to generate, you're burning tokens to even clean, source, and validate the answer.
Well, it's more than that, right? Burning tokens on initial prompt input, and then if it's thinking, you're burning tokens on the thinking.
Correct.
Then you burn tokens on the output.
Yeah.
And now if you've got to do that all for 2 or 3 models on the same thing, this is where you've got to really start to think about your solution architecture on how are you putting those security and those other frameworks in. It's going to drive back to what I was saying about there's a lot more benefit for small model versus big, because I can run a couple of small models for the price of one giant one sometimes.
Correct. And you could run it in your infrastructure without paying per token. It's just there in there. Of course, you have to pay for the infrastructure and electricity, but yeah.
But the other problem right now, have you looked at the price of DDR5 RAM recently?
No.
I was talking with a different team that we do some work with, and they're sourcing some new hardware for a project. And this is for an embedded project, a little bit different than our world, but they were seeing 30, 40%. I was seeing other articles that DDR5 is up 60%.
Wow.
I've seen some that's even more than that because everyone's buying all these servers. So now you can get the GPUs, but you can't get the RAM.
That's an interesting problem. So we need more silicon.
It's always the challenge. It's always the challenge.
Yeah.
So since we kind of delved into hardware on that one, we were talking about another thing from Sunday Robotics, which I thought was really interesting on how they're approaching training and what they were doing.
Yeah, it was very unique. The way I kind of looked at it was like they're collecting data even without a robot and just a human. It's kind of like the VR glasses, but they have more telemetry being picked up from the hand gesture. I think they have built a device.
So they had built gloves. So
Right.
we had talked about a previous paper where the university was using the Orion, which were, I think, the early Meta glass with the cameras and the screens in them, the engineering prototype that people were using. And so they had people going through tasks, and they were using that to go train a world model to go train robots. So what Sunday's done is they've created some grippers or gloves that are basically the same characteristics as the robot's hands. And so what's interesting about that is it's got a camera and it's got force feedback sensors. Because that's one of the challenges when you're dealing with a robot, right? We kind of know, don't squeeze an egg too hard or it might break. A robot doesn't know that.
Yeah.
So
I think it adds a layer of additional sensor data. If you look at the optics based, the models are really, really good at tracking skeletal features, fingers, and all of that stuff. The force feedback is an interesting problem, to fit, because you need that to grasp, make it an everyday robot, or it becomes more. Hey,
but that's a super important part of you go from, okay, we've got these general robots that can do a fixed task repeatedly to something that's more universal. First thing you got to do is figure out navigation, get the robot from point A to point B.
Right.
Then you got to figure out the high level kinematics of a movement. But the hardest thing, and this is what Amazon has run contests for years on, is how do I do the pickup and the grip? So whether you have a hand-based actuator, or you're playing with a soft robotics where you're using like a sand or another material in it so you can do the gripping or suction. That last piece is the hardest part of, I've got the robot all the way to the last inch, but how do I get it to interact with what I'm trying to touch?
Right, because so the vision-based thing doesn't kind of limits that where how much your grip strength is gonna be, right? It can figure out the grasp angle and some of the fundamental models, like when you call it to pick up a red ball, this is the way to pick it up, or those kind of common sense. But a lot of that doesn't have that grasp sensor, right? Kind of a thing. So it makes sense to integrate that. I'm kind of excited to see how that develops and build out.
And they were doing some other interesting stuff, right? In their write-up on the model they created, they talk about going to different Airbnbs to test it in different facilities. But the first thing they were doing is they were testing it in real life homes, right? So they weren't just testing it in labs. They were testing it in homes with pets and other things and figuring out how to get all that data. And that, I think, is going to be very interesting to see how that applies. Because we've done a lot of work at looking at applying robotics in spaces where humans are interacting.
Right.
And that's one of the challenges is how do you make sure the robot understands how to deal with unpredictable people and does not accidentally smack somebody or get knocked over because it's not the person wasn't paying attention. I think they will probably integrate with some kind of reinforcement learning, because you can't get every scenario mapped out. When you run into something novel, how do you kind of test, right? As you are trying to pick it up, how do you change your grip and all of that stuff? I think this is going to be R&D project for them as they go into it. Well, and I think that's going to be one of the challenges of using robots in like a home or a general use environment is how do you help someone who doesn't understand that kind of training process really figure out that, hey, a tomato is a lot different to grip than an apple. They're both red. But one's going to squish. I think they fall into the domain of world models, they call it, right? These days. So it's probably they are taking multimodal was vision and sound and then text, right? Now this is going into force sensing, touch, and
maybe temperature will come into play as well. All of that will start to build up.
And there's some other things. There was the model we were talking about, I think last week, about where they were teaching the robot how to fall properly. So it protected the robot and all that, right? That's something as a human, some of us learn. If you play sports or get into stunts or get into combat, martial arts or any of that, you kind of learn how to take a fall. But there's an art to it, right? To do it without hurting yourself. Minimally hurting yourself. And so how do you teach a robot so that it like doesn't fall on the Jetson on its back and break the $4,000 computer? So that was another really interesting one that I think we're going to have to work through as people work with the tech.
Yeah, it was interesting when you mentioned that. I knew a pianist once, and she told me that, even if she falls, she will try to protect her hands because that's their main thing, right? So it's interesting. Whereas if I fall, I will try to reach out with my hands to grab something.
But that's when you learn, right? You've got to learn, like, there are certain ways you can fall. Like, you don't really want to put your arms out to block you because it's going to break wrists and arms. Like, if you fall back, you want to try and fall backwards. You want to try and protect your head by curling it up so you don't come in back contact with it. If you either fall enough or you've been involved in some of that, you kind of learn the hard way to do it. But
it would be interesting because the robots, most of the common ones are humanoid shaped, right? As they change into other shapes and forms, then that equation's going to change even more, right? It's now not protecting the backpack. It doesn't have a backpack. Maybe it's a sphere. Who knows, right?
Well, and I think that's going to be an interesting thing as robots develop, because we are taking a very anthropomorphic approach to developing them. But I was talking with some people in a different industry because we've spent a lot of time in industrial and other things where if the robot falls, it's not a big deal, but normally they're bolted down and in place. In this particular industry, if the robot were to fall, the risk implications of that robot falling, what it could do in that scenario, were very dangerous for the humans in the environment. Not the act of the robot falling, but the materials it might knock over. So you start to think about, well, does it really need legs? Why not have a set of arms on a set of wheels? Which could be a less expensive robot overall anyway, because I'm not spending the time to deal with all the balance algorithms.
Or you could have 4 legs like those Spot or something like that. They have a lot less chances of tripping over or falling over. So,
this means I get my chance to get one of the 6 or the 8-legged arachnid style robots.
Right.
I've always wondered one that would climb walls, because that would just most people would be a little freaked out by it. Let's be honest.
But it's interesting because the world model as they develop, they are around bipedal, humanoid looking things, but they
or cars usually. It's usually those two.
Cars
now,
is the other one.
I know the Omniverse one does have support for bipedal, like ones with more bird style legs and some of those other variations of that. If you remember those Disney robots that came out last summer, those were all trained in an NVIDIA Omniverse model.
The Isaac training suite, right? I think in the last week you sent me something very similar, but it was on a much lower end hardware, but it was still, we got to look into that and see if we can put up something when that is an interesting area of research for sure.
Well, I think with the DGX, so we got to get back to doing demos.
That
would be a good thing to see if we can get running on that, because that would be actually a really good use case. Because as we've looked at that, the DGX is cool from a form factor perspective, but as we've seen from some of the things where we're talking about performance, it's not necessarily a massive performer. But that's one where I suspect it could be interesting, because instead of having to go with like a dual A6000 system or something like we built, that I bet you could do on that and not have some of the same impacts from the token generation stuff we're seeing.
It's possible. I think the beauty of the DGX is the form factor, so you can slap it onto a mobile device and
the power consumption.
And power consumption. Those do matter, right? When you don't need that much of a horsepower to it's kind of a mini data warehouse, the way the NVIDIA has been placing it anyway, right? It's a smaller form factor. If you're running inference jobs, if you're running massive models, you really don't need H100s, right, to do this. You can run on this at a much lower price point. So
what I would say is it depends on what models you want to run from inference, right? This is where a number of times I've seen, like, NVIDIA will put out a really cool NIM, I think is their container setup, right? They'll put out like a NIM or one of their NVIDIA container setups for a really cool OCR solution. Like they did that with Dockling. But it's like, and then you look at it, it's like, requires 80 gigabytes of video RAM to go run. So that's one of the things I think where there is some opportunity for the DGX.
we haven't played enough with it, but I think the libraries are also catching up because a lot of the torch and all those haven't been up to date. At least for like 2 weeks ago, we looked at it. It was lagging behind quite a bit. So once they catch up,
It's the danger of the newest hardware sometimes.
yeah, but it's pretty cool. It doesn't heat up. It doesn't blow up even with that much of a horsepower under the hood.
Yep.
So yeah.
Cool. Well, I think this will be a short one for Thanksgiving. Hopefully everybody enjoys this. Please like, subscribe, leave questions, leave comments. We'd love to hear your feedback so that we can understand how to continue to make this content valuable for everybody. I won't wear green shirts anymore. I've learned my lesson. Any closing thoughts, Saurabh?
No, I think we covered some interesting papers today. Love to have some demos next time we show up.
Yep.
But yeah, I think the security piece of it we have covered quite a few times now. But maybe we can put up a demo to see how that whole thing works and go from there.
Yep. Cool. Well, thanks everyone.